Section number 28 is factoring trinomials whose leading coefficient is not 1. Something other than 1. And we actually done this type of problem before. We are going to factor by grouping. You take the number of x squares and you multiply it by the constant. In this case, you get 6. Now, you want two numbers that multiply out to 6 that add up to the number of x's, that add up to 7. Two numbers that multiply out to 6 and add up to 7 are 6 and 1, 1 and 6. The order you write it in doesn't matter. Plus 6x plus 1x. That's how we're going to handle the 7x's, the plus 7x's. Like this 3x squared and the plus 2, they don't change at all. And we group the first two terms, we group the last two. And since there's a plus in the middle, that sign in the middle bracket is fine. And that equals the top line. Remember, if this sign in the middle were a minus, then whatever that sign is right there, plus or minus, it gets changed. Let me factor the first bracket. You can pull out as 3x. 3x times x is 3x squared. Plus 3x times 2 gives me 6x. And in the second bracket, there's really nothing to factor out. So you say you're pulling out 1. After all, 1 times x is 1x, and 1 times 2 is 2. Now we factor the whole mess. This is common in both of the terms. This is one term plus, this is the other term. Plus and minus symbols, not in parentheses, separate the term. I can't argue that that's a plus sign, or that's not a plus sign. That's a plus sign, and so is this. Why don't they separate the terms? Because they are in brackets. This is the only addition or subtraction symbol not in brackets. So to separate it from the two terms. I factor out what's common, namely x plus 2. What's left over is 3x plus 1. And there's the answer. We factored it. You can check. Multiply x by 3x, you get 3x squared plus 1x plus 6x, yes, plus 7x plus 2. So we got 3x squared plus 7x plus 2, which should be exactly what's on the top line. If it isn't, either we just multiplied out wrong, we had an error in our check, or we have an error in our problem. You factor by grouping if the leading coefficient is not 1. Try another one. Suppose you have 5a minus 5a squared minus 16a plus 3. How do you factor this? You multiply those and you get 15. And you're looking for two other numbers, or possibly the same numbers, like 5 and 3. Then multiply out to 15, but add up to negative 16. And the two numbers are negative 15 and negative 1. Both of them are negative, so you can't get a positive there. So instead of negative 16a, we have negative 15a minus 1a. And we still have the 5a squared in front, and then plus 5a squared in the front, and a plus 3 in the rear. And now we are going to group. No matter what, you can always group the first two. Minus. And then you group the second two, 1a plus 3. But since there's a minus here, it won't be plus 3. It will be minus 3. You have to change the sign. In the first bracket, you can factor out 5a. 5a times a. 5a times a gives you 5a squared. Minus 3. 5a times negative 3 is negative 15a. In the second bracket, there's nothing you can really factor out. But you can always factor out a 1. We need to write down something. So between this term and that term, a minus 3 is common. Write down what wasn't common, namely 5a minus 1. 5a take away 1. That problem is done. Now, like I always say you should do this, but most times I forget to do it. But you have two, well, let's pause on that. You have two, let's do this problem. Since this is not a 1, we multiply those two numbers, we get 24. Now I want two other numbers that multiply out to 24 that add up to 10. The answer can be 6x and 4x, or 6 and 4. So instead of plus 10x, I write plus 6x plus 10x. And the 2x squared and the plus 12, we put them down. And we group the first two. Never have trouble grouping the first two. You may have trouble grouping the second two, but that's a minus. But since it's a plus, you can group the second two. Remember, if that happened to be a minus, then just change that sign. First bracket, we can pull out a 2x. And what's left over is x plus 8. From the second bracket, up. That's the 6. I read it incorrectly. It was plus 6x. I wrote plus 16x in error. And 2x times 3 gives me 6x. And the second bracket I can pull out a 4. And the reason I knew I was wrong is I was able to see the future that this was x plus 3, but this was x plus 8. They were different, so I knew something was wrong. But I fixed it. I factor out what's common, namely x plus 3, and I write down stuff that isn't in common, namely 2x plus 4. And like always, whenever you claim you're done with the problem, whether I ask it or not, you should ask yourself, can you factor out x plus 3? No. Can you factor anything out from here? The answer is yes. You can factor out a 2. And then you get x plus 2. 2 times x plus 2. Now, we spent a lot of time doing this last problem. It was long. It was a pain in the neck. Because we had a factor by grouping. And the reason this could have been a lot easier, the reason we didn't do it more easily was we didn't ask ourselves, can we factor out anything? I can factor out a 2. 2 times x squared is 2x squared. 2 times positive 5x is positive 10x. And 2 times positive 6 is positive 12. Okay, that wasn't very hard. But now it becomes easier. Since it's x squared, I'll factor what's in these parentheses as x followed by number times x followed by number. Two numbers that add up to 5 and multiply out to 6 are positive 2 and positive 3. The exact same answer I got before. You really should try to factor out first, especially when it goes from when the problem starts as a polynomial or a trinomial where the leading coefficient is not 1 to factoring a trinomial whose leading coefficient is 1. You need to catch that. We went from a trinomial or trying to factor a trinomial whose leading coefficient was not 1. That's what we did over here. We factored a trinomial whose leading coefficient was not 1. In the new case over here, we factored out the 2, and then we were left with a trinomial that we wanted to factor, but its leading coefficient was 1. That was a piece of cake. I didn't have to use the grouping technique. Okay, try to factor out what's in common first. And you need to ask yourself that. I may not ask it, and the reason I don't ask it is because I don't see anything I look so quickly that to see if anything's common, I don't even realize I'm doing that. So I don't mention, oh, I don't see anything common. Okay. Now, do a couple more. Suppose you have 2x squared minus 5x minus 12. And you cannot factor out anything, in particular the 2. So you multiply the coefficient of x squared by the constant. And you get negative 24. And you want two other numbers to multiply out to negative 24. So one's going to be negative and one will be positive, making sure that positive is second. And the two numbers should also add up to negative 5. So negative 24. You have 1 and negative 24. Notice I'm letting the larger number be negative. 2 and negative 12. Here it is. 3 and negative 8. 3 and negative 8. Negative 8 and positive 3, they add up to negative 5, and they multiply out to negative 22. Okay, so that's one big chunk of that problem. So now we rewrite the top line. The 2x squared stays the same, but the negative 5x becomes negative 8x plus 3x, and don't forget the minus plus. And then since we have a plus in the middle, you can just group the first two and the last two. And this equals the top line. Don't ask me why the 2 didn't come out, I'm sorry. So now we factor out from the first bracket 2x. 2x times x is 2x squared, and 2x times negative 4 is negative 8x. In the second bracket, we pull out is 3. 3 times x is 3x, and 3 times negative 4 is negative 12. Now, between this term and this term, they are separated by the only addition or subtraction symbol that is not in brackets. Those are the two terms, and they both have like factors, namely x minus 4. And what wasn't underlined was 2x plus 3. So that goes in its own bracket. Okay, now we're just going to do one more problem. It's going to be very similar to the one we just did. Suppose you were given that problem. Well, it looks like it's a polynomial in x squared. So what is this and this doing here? What are the y's doing there? So you say, well, next in the x term, it's a y. So in the constant, I would like to see y squared. And I do. So then I say, well, what I'm going to factor is 2x squared minus 5x minus 12. That is, temporarily, I'm going to ignore the y and the y squared. But coincidentally, that's the problem we just did, and when we factor, we get that. It is when you factor 2x squared minus 5x minus 12, you get x minus 4 times 2x plus, that was just a 3. I didn't mean to put an x. 2x plus 3, sorry. 2x plus 3. So this up here is going to be very similar. It's going to be x minus 4 times 2x plus 3. But whatever was by the x term that we removed, in this case a y, that goes by the constant. And it's done. Just like before, except now we had a factor by grouping. If somebody gave me this problem, I would first factor this here. I would first factor this, get my answer, and then sneak in y on the end. Okay, that completes section number 28. Factoring trinomials with leading coefficients is not 1. Something other than 1. But keep in mind that you might be able to factor out something to make them 1. So then you go back and you call it a problem of section 26.